So today I'm going to be using M&Ms and Starburst candies to represent different amino acids to show how mutations in a DNA coding strand can affect the proteins that are produced. So here we have a normal coding DNA sequence that can be transcribed into this mRNA complementary strand, which will produce methionine, tryptophan, isoleucine, threonine, cysteine, and a stop codon based on the triplet code. So now we're going to move on to our first mutated strand. So as you can see, it is also in the 5' to 3' direction, and through the process of transcription, this complementary mRNA strand is produced. So this mRNA strand codes for methionine, cysteine, isoleucine, threonine, cysteine again, and a stop codon. So as we can see, here is the point mutation that we see, where a G base is changed to a C base. So this is an example of a transversion, and as we can see, it does code for a different amino acid than the normal strand does. So this is an example of a missense mutation. So now we move on to our second mutated strand. So we have this DNA coding strand in the 5' to 3' direction that is transcribed to this complementary mRNA strand, which codes for methionine, tryptophan, isoleucine, threonine, a stop codon. So as we can see here, the C to A base pair change is a transversion, and it resulted in an early stop codon, as the original stop codon was here. So this is an example of a nonsense mutation. So now for our third mutated DNA coding strand, we have this, which is transcribed into this, which codes for methionine, tryptophan, isoleucine, threonine, cysteine, and a stop codon. So as you might notice, this is the same as our normal DNA coding strand produced. So this means that this is a silent mutation, which does not change the protein produced. So we have a T to a C base change, making it also an example of a transition. So now we'll move on to our final example of a mutated DNA coding strand, which transcribes this mRNA sequence. This will translate to methionine, tryptophan, isoleucine, threonine, cysteine, leucine, proline, and cysteine again. So as you can see, there is no stop codon that will be translated, so this means that this is a read-through mutation, as it will just keep going for as far as we know. So this G base change to a T base change is also an example of a transversion.